Good morning to respected sir. Good morning to everyone present here. I am Simranjeet Singh Chabla. Me and my team will be giving a presentation on the topic of our term paper, that is Safe Terrestrial Route Recommendation System using GIS. I would like to start with discussing the motivation behind this topic. Is that first, if we see that road safety is considered to be a significant issue and one amongst the foremost causes of death and injury across the globe. And as a matter of fact, the number of accidents are higher in the developing countries rather than the developed countries. For example, a country, India, is a developing country. So we have the data on it. That is, on an average, there are 1,317 accidents and 413 accident deaths on Indian roads every day. But it can also be seen in this way that there are 55 accidents and 17 deaths every hour. So this matter needs to be take a look into. So in this paper we have taken a particular interest to make some kind of efforts to reduce the accidents. Now I'll be discussing our proposal, and that is what we did is that we classified the type of accidents into different categories, and based on this classification we analyzed different causes of accident. Throughout the analysis we made a conclusion that most of the accidents happened because the user was not cautious enough. And the reason behind the lack of cautiousness of the user, we believe that is the lack of knowledge about the route that he or she is taking. So we are trying to make the user cautious before the journey by giving suitable accident information about the routes available. So now I'll be discussing some data acquisition and feature extraction part. In this, with the help of OpenStreetMap application programming interface, we created data frame of node and edges and tried to extract the geometry from the edge data frame and find different kind of features. And the image for the same has been shown here. And now the implementation part will be giving my fellow teammate, that is Shuvodeep Debnath.
Thank you, Simranjit. So the implementation part has divided into three stages. So first of all, we collect the data from the Ministry of Transportation, the accident data. So this accident data contains defined road features, different type of residential area, different type of junction, and attached with that number of accident occurs, number of person killed, number of person injured. So these data are stored in year wise, like 2018, 2019, 2020. So in this data, first we label this data. Means what is the label this data means? So label this data means we have, if suppose in a bridge is a road feature, and if in a bridge number of accident occur increasing, number of accident increasing in year, and also number of death and number of person injured also increasing every year. So this is a, we declare label this data as a high accident zone. If something happen in reducing the accident or reducing the number of person killed, so this is be the lower accident zone. Based on this higher accident zone, lower accident zone, or mid accident zone, we have assigned some weight to every feature. Now what Simran has already did, we told, we have taken data from OpenStreetMap API. So after giving the place name in OpenStreetMap API, we can create two data frame, node data frame and edge data frame. So node data frame contains the junction of the road, and it is saved as point ID in latitude and longitude. Along with that, the number of lanes attached with the junction. In the edge data frame contains that shape as line string, and also there are other features like whether it is a bridge or it is a tunnel, etc. So first of all, from that data frame we label that junctions, edge, bridge with our accident database. Then we extract the geometry part from the edge data frame. In edge data frame we have in geometry part we have only the line strings. Now user will give source and destination in terms of latitude and longitude. Based on this user source and destination, we calculate all the possible paths from source to destination. And now we give the weight of this all possible roads and find the minimum weight road in this path. So this minimum weight path will be the safest recommended route. Now we see the algorithm. So in the algorithm, safest route recommendation, it is taking input road network G and L as label data, source and destination. So we find first the nearest point in the graph network from the source. So for this we have taken distance spatial operation. So distance spatial operation gives the point of source and destination to nearest point of source and destination in the road network. So we have taken the point in the road network, and now we finding the all possible path. One thing we have taken the tolerance delta, because every path may not be connected to other path. Maybe there are some disjoint in that part, so that to avoid this problem, we have taken a tolerance. So we find the all possible path and give the weight. Now we find the minimum weight from that possible routes, and this minimum routes will be the safest route recommendation for the user choice. Now we will see the output. Yes. So here there is a we have made application. Here user gives that longitude, latitude, source and destination, and the optimal route as the route name sum. There are some route names, and if we plot this route name into the Google map, so this will show like this, and this is the optimal safest route, not the optimal shortest route. There is further discussion and conclusion which will handled by others. Thank you.
Thank you, Shuvodeep. In this section, we'll be discussing existing work that has been done in this domain. Integrated Road Accident Database, which is known as the IRAD, is an initiative by the Government of India in order to improve the road safety in the country. It is being implemented over 59 districts, and it helps us to identify the cause of the accidents. Various other research have been made in the areas using the lowest crime rates, where the system would be recommending route based on the lowest crime rates. Another would be based on the user feedback. You might have heard about local guides that Google Maps follows, and we'll be getting rewards based on that. And this could be treated as a crowdsourcing that is done by the Google. Now we could see another recommendation system that is done using the GPS. Mostly the GPS will be embedded in each vehicle and using the congestion protocol, and we'll be able to get the congestion data using this GPS, and maybe we can recommend a route based on this data. Another recommendation system is based on the real-time accident data. What happens here is, if an accident occurred at a certain place, a system would be recommending the user that this route may not be safe to travel. So all these models that we have discussed now is either the real-time data or the statistical analysis have been used. But our research is based on a survey of a long-term data, which could help us to classify our model to make clearly classify accident-prone areas, as well as effectively detect all these data. Now, talking about the conclusion part, what happens is our model is pretty much efficient in order to recommend a safe path for the user for the specified source as well as destination. We'll be using mainly the road features, as well as we'll be giving a weather data as well, so that user may choose upon that. Now, a proper mapping of accident prone area has also been done in our model, and this could be integrated in various taxi booking applications like Uber or Ola, so that the driver could choose the safest path to ride. And this could be treated a wonderful a wonderful innovative idea for the pedestrian as well as vehicles in order to get or be safe while traveling. And due to the limited time constraint as well as the lack of data available, our model may not be the best at this point, but we in the term paper we had included a mode of measuring or evaluating our model, how it can be useful compared to other existing works. Once the entire data set has been put into this model, our model is believed to be one of the best in this particular domain. And yes, if you have any questions, we are happy to answer that.
Thank you. Good presentation, good work. First of all, one thing is that while that is again not non-technical suggestion, that initially when you are starting, the title slide should have the name of the authors or name of the contributors, right? That is missing in your slide. So that you should be careful. Name and affiliation is title, name, affiliation is mandatory, whether it is a paper or anything. Right? Aja, just I might have missed that part. What is your, how do you define road safety? Means how you characterize the road safety? What are the
Road
factors?
safety could be different.
No, for your case actually.
Yeah, fine. The road safety could be classified in different terms actually, probably based on the gradient of the road, or it could be based on the crime rate, or it could be based on the accident data that is already available for that road. Here we are,
Yeah,
here we are,
please.
yeah, here we are utilizing that accident data which are already available from the Ministry of Road Transport, as well as probably the gradient that could be done as a user feedback, or it could be treated as a crowdsourcing at the later stage of the implementation.
Okay. So that means in your model, if I provide you crime data, your model can accommodate that.
Yes, surely, sir.
That is
Like
good.
our model is a general model. Here now we have just used the accident data, but any type of data could be incorporated into that.
This model is proposed by you, right?
Yes. No other implementation of this kind of model is available. That's right.
Very good. Another thing, see, this sort of data are has a temporal dimension, right? Over time, it changes.
Yes, sir.
Yes,
We have taken care of that. We are using the change in percentage. For example, in 2018 it was something, in 2019 it is something. So if there is an increase, so we'll be acting on it.
Oh, fine. That's good.
it would be like probably if you consider the monthly data, it would be more accurate. Currently,
Sure.
we are considering the
No,
year.
what I mean to say, your model can accommodate that.
Yes, surely.
Fine. This is fine from my end. Anything from Subhabrata and Riya?
Yes. What is the time complexity of your proposed algorithm?
It could be in parallel with the fluid Warshall algorithm. Like it would be of log n, big of n cube, where we find the shortest pair for all the nodes, and that would be the maximum time taken by our algorithm.
Okay, and another question, that Dijkstra's algorithm that you mentioned,
Yes.
that is different from your model, but Dijkstra gives us the minimum weight path. So
Yes.
my question is that means are you comparing those two, your algorithm and Dijkstra?
No, sir.
We are actually we are taking the feature of that Dijkstra, and that weight again would be defined by our side, because that weight will be decided by the accident data, all the analysis that we have done on our data set, and we'll be updating that weight based on that. Then we'll be utilizing that feature of Dijkstra to compute the shortest path, so that we'll be getting the best and optimal safest route that is available.
Right, and another thing is that the shortest part may not be the safest one, right?
Yes, sir.
That we have also. Yes.
ठीक है. Okay, thank you.
Okay, good. Riya, you have anything?
No more question. They did a really good work.
Okay. Thank you, the full team, and thanks for all for participating. So we'll have the group 5 to 8 today, 7 to 8, right? So all
Yes.
are encouraged to join. You listen to different aspects. But if you have other one, that is fine. But you are gone. Okay. Thank you.
Thank you very much, sir.
We'll stop here.
Thank
Okay.
you very much,
Bye.
sir.
Thank
Thank
you.
you, ma'am.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.